All right, hello, this is Mr. Gable, and here are the things you're going to need for today's math work. You're going to need your iPad, pencil, and you will need your math notebook. And remember, when you see that math notebook sign, add to your notebook, please make sure you're doing that. So today we're going to work on distance equals speed times time, and that's the formula for calculating distance or calculating speed or calculating how much time it would take to go that distance. So today you will work to have a better understanding of how to work to use the formula distance equals speed times time. All right. So let's jump into this work and see what we're talking about. So here's our first question, and this I want you to add to your notebook. So make sure you've given the notebook the title distance equals speed times time. So we've got Saul, and Saul was planning a trip to his mother's house. He's a good boy. He's going to see his mom. And he knew he had to drive 715 miles, and he also knew that he drives on average 55 miles per hour. And you know, over a long trip, 55 miles per hour, that's pretty good average speed. So how long will he be driving? That's what Saul wants to know. Is, what kind of time should he expect? So if we look at distance, well, we know that's 715 miles, and he's going to average about 55 miles per hour, he thinks. And then we've got to just figure the time. So the time is the unknown. So if we take 755 equals 55t, we can divide both sides by 55, and we're left with 13. So Saul's trip would take about 13 hours. And that's not bad for going 715 miles. That's a long way. All right, let's keep taking a look at this. So we've got two problems here. A trip to Chicago from Dubuque, Iowa is 180 miles, and if the roads allowed for a speed of 50 miles, how long will it take? So here we're going to solve for time again. So we're going to write out that formula, d equals s times t, distance equals speed times time. So we know our distance, that's 180, and we know our speed is 50 miles per hour. That's what you can legally travel. And we're going to multiply that times t, because that's our unknown time. And when we do that, we're going to get 50t, or 180 is equal to 50t. Divide both sides by 50, and we're left with the distance, or t, excuse me. T is equal to 3.6. Now, 0.6 doesn't mean 6 minutes. It means 0.6 of 60 minutes. So we have to take 0.6 times 60 minutes in an hour, and that gives us 36 minutes. So it's going to take 3 hours and 36 minutes to drive from Chicago to Dubuque. All right, let's take a look at this one. Isaac, he'll be attending a meeting 252 miles away from his home, and if he sets his cruise control at 48 miles per hour, how much driving time should he plan for? So first of all, we should probably really wonder why he's traveling at 48 miles per hour. But anyway, let's do the math. So again, we know the distance, okay? We know the distance, and we're really trying to find out how much time. So distance is equal to 252, and he's going to be traveling at a speed of 48 miles per hour, and we want to know the time. So that leaves us with 48t is equal to 252. We divide both sides by 48, and we're left with t is equal to 5.25. Now remember, 0.25, that's 0.25 of an hour, so that's 0.25 of 60. So it's a quarter of 60, which is 15. So it's 5 hours and 15 minutes for Isaac to travel that 252 miles. All right, so that's just finding and using the formula of distance equals speed times time. Let's do one more together. Please add this one to your notebook. So we've got Juan, and he rode a bus across the entire country at an average speed of 60 miles per hour. And if the trip took him 48 hours, how many miles did the bus cover? So here we want to know distance, okay? So if we look at this, we write out our formula, distance equals speed times time. We don't know the distance, so we've got 60 miles per hour for 48 hours. Wow, that's a long time to be traveling. Hope they change drivers. And that would mean that they traveled 2,880 miles. All right. So again, just using that formula and then plugging in what you know and then solving for that unknown. That's really how you use this formula. But let's take a look at one more, because this one's kind of cool. So we always are encountered with these trains leaving stations. So this train A leaves the station and is heading north at 80 miles per hour. At the same time, from the same station, train B heads south. So they're going in opposite directions at 65 miles per hour. How far apart will they be in 3 hours? So really, we just need to calculate their distance. So train A is 80 times 3. They've gone 240 miles in 3 hours. Cool thing about trains on rails, they don't have to stop. And then here we have train B. Distance equals speed times time. 65 times 3, 195. So train A is 240 miles away from the station. This train B is 95. So that means together they are 435 miles away from each other, because we can add those two values together. All right, so those are some different ways to find and use that formula of distance equals speed times time. But now let's talk about average speed. You encountered this in our math challenge yesterday, and I think some of you kind of did the problem like this. So here's our problem. Jay walked. He walked a mile at 2 miles per hour, and then he rode his bike for another mile at 10 miles per hour, and what would his average speed be? So a lot of you wanted to take 2 plus 10, say, and get 12. That's good, and divide by 2, because there's 2 data points, and get that average speed of 6. But that's not quite how we do these. It's a little more complicated than that. So when we do this, you have to really figure speed averages differently, and you must think differently. You must think in blocks of time. And since 2 is really 5 times slower than 10 miles per hour, then the time Jay spent walking was 5 times longer than the time that he spent riding his bike. And because of this, you must give the walking 5 blocks of time. So let's take a look at what, let me show you now what I'm talking about. So again, we know that 5 times 2 is 10. And so here, if we say, all right, mile 1, he walked at 2 miles per hour, but that was 5 times slower than mile 2, because mile 2, he's on a bike, which that's the best way to travel. We all know that. No bias there. Anyway, that's 10 miles per hour. And this, so now if we take these blocks of time and we think of this is 5 blocks of time at 2 miles per hour, and this is 1 block of time at 2 miles per hour, then we can start to say, all right, now we can start to find an average speed. So here we have all of these 2's add to 10, and then this 10 is there. So 10 plus 10 is 20, but we have 6 blocks of time, so that 6 is what we're dividing by, and then that gives us an average speed of 3 1/3 miles per hour. So it's a lot slower than that answer that we might have gotten if we had done it wrong, which we certainly would have gotten it wrong if we said 6. So this is really what you need to think about. Now I've got a couple more problems here, so stick with me. So here's a slightly harder problem. A student is driving to school at 50 miles per hour, and a quarter of the way there they run out of gas. Okay, and now this student is going to run the rest of the way at 10 miles per hour. So what is the average speed? Okay, so this is a lot harder problem because we've got to draw a chart first. So here's the trip broken down into 4 equal parts. The first quarter of the trip was 50 miles per hour, and then each of these is 10 miles per hour. So again, each of these parts is 5 times, took 5 times longer than that first quarter of the trip. So the student spent a lot of time going 10 miles per hour and a very little time going 50. And so if you look at the picture, it is clear that each 10 miles per hour represents, should be represented in 5 blocks of time. Okay, so in doing that, then we are left with, we're going to add up all of these, which each of these is a 50, so 50 plus 50 is 100 plus another 50, 150 plus that 50 is 200, and there are 16 blocks here of time, so now we have 200 divided by 60. That gives us an average speed of 12.5. Now, if you apply the test of reasonableness here, that makes a lot of sense because he spent more time running at 10 miles per hour than he did at 50 miles per hour. So it should be closer to that 10 miles per hour than 50 miles per hour. All right, that one is a lot harder, and I think if you listen to that one a couple times, you'll understand it. So now let's talk about Sarah. So Sarah walks to school at 4 miles per hour and she runs home at 12 miles per hour. What is her average speed? So again, she's going to run she's going to run to school. And if we think about this in blocks of time, Sarah is going to spend 3 times longer walking to school than she will running. So we have to have 3 blocks of time, each at 4 miles per hour, that represent her trip to school. And on the way home, she just runs home at 12 miles per hour. I almost sometimes think of these as like finding a common denominator. So here we have 3 fours is equal to 12, and we have 12 here. So when we look at what we have to do now for the math to find the average, 4 plus 4 plus 4 plus 12, that is equal to 24. There are 4 blocks of time, 1, 2, 3, 4. So we're going to divide by 4, and that leaves us with Sarah's trip home and to school averages out at 6 miles per hour. Pretty good, Sarah. All right, last one. I'm pretty certain this is the last one. So Kristen's going to hike up a mountain at 2 miles per hour, and she hikes down the mountain at 5. What is her average speed? So I've got a great drawing here. And you might be saying, well, wait a minute. She walks down at 5 miles per hour. There should only be 1.5. Right, but to really be able to talk about this and compare this equally, we need to have things that equal each other. So 5 2s is equal to 10, and 2 5s is equal to 10. So we're going to give 2 blocks of time at 5 miles per hour, and that equals 10 total, and so we need to have something equal on this side. So those two equal out. This is her trip up the mountain, and this is her trip down the mountain. And so when we do this work, we're going to get this here, 2 plus 2 plus 2 plus 2 plus 2 plus 5. That's going to equal 20, and we have 7 blocks of time total. And so the average speed, or average miles per hour, is 2.86 miles per hour. Almost 3 miles per hour. Not bad for hiking up and down mountains. It's definitely harder going down a mountain than it is going up. You might argue that with me, but if you've done it and you've really hiked up a long mountain, it gets very tiresome coming down. But that average speed makes a lot of sense. All right. So now what you're going to do is you're going to get some time to practice. So in our distance equals S times T folder in our Schoology course, you're going to be looking for speed L1 1 through 10. There's 10 problems. I want you to do, you can choose to do the odd, you can do the even, or if you really want, you can do all 10 problems. Pick some hard ones, pick some easy ones. You have to do 5, but you can certainly do more. All right, I hope this is helpful, and see you soon as we are calculating speed.